Hi friends, welcome to Civil Studies. Today we will discuss about ionization potential energy. In previous classes we discussed about atomic size and the screening effect. Today we will discuss about ionization potential. It is very important topic in chemistry which is useful for all competitive exams. Okay, first we discuss about what is meant by ionization potential, how and what the trends of ionization potential in the periodic table, and what are the uses of ionization potential. Okay, first we see the definition of the ionization potential. The minimum energy required to remove an valence electron or most loosely bounded electron is known as ionization potential energy. Okay, now I am drawing an atom. This is nucleus, first shell, second shell. Okay, in the first shell they contain only 2 electrons. On the second cell I kept 4 electrons. Okay, here what is the most loosely bounded electron or the valence electron in this atom? Okay, first we discuss about what is the name of this atom. 1, 2, 3, 4, 5, 6. 6 protons is equal to 6 number of electrons. This atom is known as carbon. This atom is known as carbon. Okay, now 4 electrons in the valence shell. These 4 electrons are the most loosely bounded electrons in this atom. So, the minimum energy required to remove these electrons is known as the ionization potential energy. Okay, first we have to discuss about types of ionization potential energy. First ionization energy, second ionization energy, third ionization energy. Okay, these types of ionization potential energies. Okay, this is the most loosely bounded electron in carbon atom. The energy required to remove. Why you need energy to remove an electron from an atom? For an atom, this is the nucleus, The electron attracted toward the nucleus. The electrons attracted toward the nucleus. So to overcome the attractive forces from the nucleus, the electron want to be removed. So we have to require some energy, some energy to overcome the attractive forces of the nucleus in an atom. So there is more attractive forces, more ionization potential energy. Less attractive forces, less ionization potential energy. So from this statement we derived as ionization potential is directly proportional to nuclear charge or effective nuclear charge. Okay? How? Suppose, once I am repeating, suppose this is an atom. In atom, the attractive forces is more. Then the energy required to overcome the attractive forces of the nucleus of an atom is more. So the ionization potential is more. Nuclear charges is less, attraction is less, and we can easily remove the electron from an atom. So the ionization energy is very less. Okay? Ionization potential is directly proportional to nuclear charge. This is one of the relations in the ionization potential. Okay, next we will discuss about first ionization energy, second ionization energy, and third ionization energy. How they will relate each other. Okay, now we will discuss about first ionization potential energy, second ionization potential energy, and the third ionization potential energy. We can write first ionization energy like that. IP1. IP1 means ionization energy 1. First ionization energy. Second ionization energy IP2. Third ionization energy IP3. Okay, we will write the names. First we have to draw an atom structure. This is nucleus, first cell, second cell. Again we take the element carbon. First cell 2 electrons, 1, 2, 3, 4. This is carbon. What is the configuration of carbon? 2, 2, 4. Electronic configuration is equal to 2, 4 for the carbon atom. Now, what is meant by first ionization potential energy? The energy required to remove the first electron from valence shell. So that means you remove. We are numbering. This is first electron, second electron, third electron, fourth electron. Okay. First, you have removing the most loosely bounded electron. That means any of these electrons, you can remove any electron. Suppose I remove this electron from the atom. Some energy X is required to remove that electron from the carbon atom. The X is the first energy X. Okay, when the electrons are decreasing, okay, here the carbon changes into C plus. Imagine carbon changes into C plus. One electron is removed. The carbon have 6 protons. C plus also have 6 protons. Okay, they have same number of protons but different number of electrons. When the electrons is decreasing in number, attractive forces from the nucleus is increasing. So the ionization potential increases. So this electron is removed from this atom completely. Okay, I removed this electron. Now 1, 2, 3, 4, 5 electrons remaining. This electron attracts the electron experiences more attractive forces from the nucleus before than this electron present. Okay, now the energy required to remove this electron is more than the energy required to remove this electron because attractive forces is more. Suppose this is 2x. Don't 2x, I imagine that one 2x. The energy required to remove the second electron is known as 2x. Okay, this electron also removed. Okay, now very less electrons, so much energy want to require to remove this electron from the atom. This is known as 3x. That like think. The energy required to third electron from the carbon atom is 3x. Okay, this like you can think. X is the energy required to most loosely bounded electron of a carbon atom. That is known as first energy. Second energy is the second electron in a valence shell. The energy required to remove from an atom is known as second ionization energy. Third ionization energy, the energy required to remove the third electron from the atom. Okay, this is the brief explanations of first, second, and third, and so on. You can how many electrons are present in an atom. That many number of ionization potential energies are present in that atom. Okay, now we see what are the factors affecting the ionization potential energy. There are so many factors like screening effect, and the penetrating power, atomic radius, nuclear charge. Okay, now we will discuss that one. Okay, now we will discuss about the factors affecting the ionization potential energy. Okay, suppose we take an sodium atom. It contains 2 electrons in first cell, 8 electrons in second cell, and 1 electron in third cell. The atomic number of sodium is 11. Okay, now first to discuss about atomic size. When the atomic size increases, one minute. Okay, I draw 2 atoms. One is potassium atom, another one is sodium atom. Okay, these 2 elements belongs to first share group. In groups, the atomic size, the number of cells increases gradually. Okay, now we discuss about atomic size. How ionization potential energy depends on atomic size. First, we look at the sodium. In sodium, there are mainly 3 cells. 3 cells. Okay, in these 3 cells, the attractive forces from the nucleus is very more compared to the potassium because there is only 3 cells. And the attractive forces can be less distance. Okay, from the nucleus to the outermost shell, the distance is less. When we come to the potassium case, the distance from the nucleus to the valence shell is more compared, very large or very more compared to the sodium. Because in sodium, how many cells? There are 3 cells present in the sodium. And in the potassium, there are 4 cells present. So the distance from the nucleus to the valence shell is increasing in groups. So the attractive forces is decreasing here. Distance increases, attractive forces decreases from the nucleus. So the ionization potential of sodium is greater than ionization potential of potassium because sodium has less size, more attractions, more ionization potential energy. In the case of potassium, It has more size. More size, less attractions. Less attractions, less ionization potential energy. Okay, now we compare the sizes. Atomic radius of sodium is less than atomic radius of potassium. From these two relations, we derived a conclusion. Atomic radius is inversely proportional to ionization potential energy. Okay, this is the main second equation. What is the first equation? First conclusion: nuclear charge or effective nuclear charge is directly proportional to ionization potential energy. Next, atomic radius is inversely proportional to ionization potential energy. Okay. Next, we see atomic radius completed, nuclear charge completed. Next, screening effect. Okay. Now we will discuss about screening effect. What is the screening effect? I already told last class. The repulsive forces from the inner electrons. Of an atom towards this valence electron is known as the screening effect. Okay, it is very simple to derive the conclusion of this relation between the screening effect and the IP. Okay, first you take sodium. In the sodium, valence shell is this one, valence electron. For this valence electron, how many inner electrons are repelling each other? Well, we have to count them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There are totally 10 electrons which are shielding the attractive forces from the nucleus. Totally 10 electrons in the sodium. Now we have to count the in potassium. Okay, this is the valence shell. How many electrons? Valence shell remaining 10, 18. The total 18 electrons which are shielding the attractive force from the nucleus. Okay, in this way, ionization potential of potassium is less than ionization potential of sodium. This relation. From this relation, we have derived that one screening effect and the IP conclusion. Okay, first, there are more screening effects. If the screening effect, did you remember or not? Screening effect is inversely proportional to effective nuclear charge. Okay, nuclear charge. If the screening effect increases, the attractions from the nucleus also decreases. If the attractions from the nucleus is decreases, ionization potential also automatically decreases. In this way, there are 18 electrons which are shielding very more. Shielding effect is more. There are 10 electrons. In sodium, the shielding effect is less than the potassium. So the shielding effect of potassium is greater than shielding effect of sodium. We have to compare the ionization potential values. IP of Na is greater than ionization potential of potassium. These are both inverse each other. So the conclusion, the relation between the screening effect and the ionization potential is screening effect is inversely proportional to ionization potential energy. Okay, the screening effect is inversely proportional to ionization potential energy. This is the main three equations which belongs to the ionization potential energy. In next class, we will discuss about the electron affinity, how the factors affecting electron affinity, what is meant by electron affinity. Okay, thanks for watching this video. If you like this video, please subscribe, like, share and comment.